Next, I'd like to introduce Dominic Trueman. Dominic is the Head of Research Implementation at the Rail Safety and Standards Board, the RSSB. Dominic is a Chartered Mechanical Engineer and a Fellow of the IMechE. With experience in track engineering, people leadership, and research implementation, he joined Metronet, or London Underground, graduate scheme back in 2007 and completed a range of placements and found that track engineering was the right fit. At RSSB, he's produced the revision of the Railway Group standards on track systems, as well as being able to contribute on a range of European working groups. He's recently moved into research department. So welcome, Dominic. We look forward to hearing from you.
Thank you. Thanks all. Is the microphone on? Doesn't sound like it. Hello. That's better. Great. Oh, well, thank you, everyone. Yeah, I'm Dominic Trueman, Head of Research Implementation at the Rail Safety Standards Board. And I'm going to talk about how we develop research, how we implement research, and hopefully get a bit of engagement. I realise this can be a bit tricky to make rail research sound that interesting. I asked ChatGPT to do it for me, and it said it couldn't. So these are my words, and I'll try and make it as engaging as possible. I know it's a third presentation here, so I'll try and convey some key messages that come out of this. So, like I said, I'll just go over what the research program is, what we do, and how you guys can contribute. I'll then talk through some examples, a few pictures of rails and trains, and then I'll just conclude about what the future is and how we can improve our research and how you can help. So the RSSB research program was set up in 2001, and it was after RSSB was set up after the Ladbroke Grove accident, but it has evolved now to underpin the drive to create a safer and more efficient railway. We look at our three types of innovation amongst our research program. There's optimization, which is where we provide sound evidence for whole system considerations. Then there's incremental innovation, which is where we look at to test and develop test improvements for existing technologies, but cut across organizational boundaries. Finally, there's radical, which is where we look to develop and test improvements to sort of pre-commercial development, which requires standardization and safety analysis. And the sort of three things I'd like to pull out from that are whole system, across organizational boundaries, and also standardization and safety analysis. So they're the big sort of pool I'd like to come out of that. Because it's what makes the research program unique, that we're looking on improving interfaces, and these are interfaces both technically and organizationally, and where whole system risk analysis is required, and where we can sort of maybe develop implementation through changing standards. So we receive a grant from the DFT, thank you, and that's what enables us to do our research, but we work with industry to ensure that the research is targeted and, importantly for me, that it can be implemented once it's been developed. I'd like to just highlight at this point that our research isn't often carried out by the RSSB, it's by external industry experts, or through our university partnership scheme by, for example, the University of Huddersfield or University of Birmingham, who do a lot of the research for us, and it's been guided by our technical experts. It's been touched on in the previous one, so I won't dwell on this, but I think it's worth highlighting how we sit amongst a range of sort of government-funded research, because there can sometimes be the allegation that we're duplicating work, but we do collaborate with these various things. So there's Network Rail, which is do their own research program, but that's very focused on Network Rail. We're working on that sort of cross-system boundary. There's UCRIN, which is the sort of university data, which we utilise a lot, and that's part of our university partnership. It's been very beneficial. Then, as was mentioned, there's Innovate UK and First of a Kind, which is a great competition. So we collaborate amongst them to really make sure there's the best use of government funding for rail research. I'd also quickly like to make reference to rail technical strategy, which is something that guides through. It's a sort of long-term program, guides where current technical research should go, and it's cross-industry. It's developed by Network Rail, DfT, RSSB, and I really think it's worth having a look at, but I won't dwell on it now, just to keep things moving. So hopefully I've provided sort of a flavour for what the RSSB research programme does, and here's what it does not. So it's looking at systematic issues. We're in a unique position where we're independent and we can support standards development and understand whole system risk. So we don't undertake research that benefits one supplier or one organisation. I think that's really key. And this distinction is crucial for guiding our future research. So we have priority work streams which help guide the research we do. You see it's a safe, efficient and sustainable rail. This is sort of Venn diagram that's mutated into a plant and implementation's a plant pot, which I dislike. As I say, I've recently joined the team, and if I make one change, it'll be removing implementation as a plant pot. And the focused areas within that are optimize operations, efficient, reliable assets, and you'll see from a presentation we took previously, there's a real sort of line of sight. So nothing should sound different to what we've been hearing. Reducing train accident risk, supporting freight growth, and that's something I'll come back to. Data interoperability, preparing for AI, knowledge transfer, and traction power management. This is just in case it's shared afterwards. This provides more detail, but obviously not going to go through it now. So finally, this is going to complete the introduction to the RSSB research, but I like this diagram and I want to bring out some key points. You can see it goes from ideas all the way to hopefully outcomes and impact on the rail industry. One of the key bits I'd like to do is ideas, and you notice that the DfT provides the strategic direction, but ideas come from industry. We will shape them and choose which ones are most appropriate, but they do come from industry, and anyone can submit a research idea. So that's my sort of my plea is that if you have ideas of cross-industry and cross-system research ideas, please let us know, please let me know. It then progresses on to doing the research, and as you can see who do the research, it's either open procurement or through our universities and our strategic partnerships. The outputs, one of my key things again I'd like to sort of change is that our outputs are not reports, they're not research papers. It's about enhancing knowledge. We have enough reports in this industry. It's about that increase in knowledge or hopefully decision-making tools. So something that really drives us on. And then the sort of second cry on, I guess, this slide is that the dissemination and implementation of outputs. So myself and the RSSB, we do as much as we can to disseminate the outputs of the research, especially ones we believe are significant and will drive real benefit. But we don't own any track, we don't maintain any track, we don't own any trains. It's the industry that needs to drive and disseminate further the research. So that's my other cry, is that if there are significant outputs, we need to drive that. And as has been mentioned, the change is difficult, that sort of progression to, I like the UPS example, but took so difficult, even though it's a really positive thing, that still takes a lot of pushing. So that's my other plea. Finally, I'll just go on to sort of the implementation journey, where we have planning, initial, advanced, and full in terms of the implementation journey. And my task is to just get our significant outputs moving along that journey year on year. That's what I'm trying. It's a challenge, though. So I'm going to go on to just a few examples of where we've managed to implement research and it's made a bit of a benefit. So the first one is regarding autumn issues. And it was highlighted by Annette, so thanks for that. It shows that alignment. And I'm specifically going to talk about a low adhesion on the rail. As you can see, there's the black leaf layer, the sort of middle picture. Apparently that I still don't quite believe it, but apparently it's got a coefficient of friction less than skis on rail. That what's a black leaf layer correct. And what I would highlight here is this is a cross-system issue. It's vegetation, it's track maintenance, it's train braking, it's signals, it's operations. So that's why the RSSB is very involved in this, because of that cross-industry thing. And I would like to talk about Sanders research, so variable rate Sanders. This is a PWI event, so I'm not going to go into sanding technology. It's train-based. Trains are there, but the main thing is that what a variable rate is, but depending on train speed, increase the output of sand being applied to the wheel rail interface. And as you can see by that chart, this sort of green to red chart, it's very effective at reducing braking distances in low adhesion conditions. So a big safety impact. I should have mentioned previously that low adhesions are a real risk. We had the Salisbury accident 4 years ago, which was a really significant rail accident down at Salisbury in the tunnel, and it costs countless delay minutes. I think hundreds of thousands of delay minutes, and I think Annette mentioned sort of about £3.5 million cost as well. So low adhesion is something that needs to be managed effectively. And when we talk about changing cultural risk and changing our mindset about how we implement change, you notice firstly it's a lot of research needs to be done, about 9 years of various research projects into this technology. And also how we look at risk. So one of the things that was highlighted when we started introducing it and trying to promote it was, what about wrong side track circuit failures caused by putting too much sand onto the railhead, so you lose that the connectivity. Our risk team did this. I think it's a really powerful image of, if you see the two spheres, of the risk of a low adhesion event versus, oh, it's just gone off now, versus the risk of a wrong side track circuit failure. And you see that it's like the sun and the earth. There's a far greater risk of that. And I think this really quite simple diagram was really quite powerful in promoting the use of sanding technology and addressing the perceived risks of signal failures, for example. So just to go through the implementation journey. So as I said, we're in a position where we can then work with our standards team to update the standard. So GMRT 2461, which is a railway group standard. So that really helps the implementation journey. But still, we need to promote findings. We need to disseminate the information across industry. That's at briefings. It's coming from RABE consultations and cross-industry events. And it has been positive now. It's being used by a few operators. I was recently at another seminar, the Vehicle Track Interface seminar, and Southwestern Railway and Northern provided some really good case studies for the initial successful use. So, and that there are more companies getting involved. So I think this is one we've implemented quite well, but I don't think we deserve a Gold Cup yet. I think more work needs to be done. This is just a slide. I won't go into it just because of time, but this is something for the pack later. You can see a bit about the testing results. The key bits I'd like to pull out of this are, but firstly, the research took a long time. We need to do a number of papers. It's not a simple one research paper and that's it. It required a lot, but also it required a lot of work with industry, changing standards, and there is more work to be done. We still need to keep pushing. I'm going to move on to a bit of research done on freight gauging, and the target for 75% of freight growth was mentioned, and this is something we're very keen on doing at the RSSB, is realising that target, and it is one of our priority work streams. I hope most of you, I think most of you will know what gauging is, the importance of gauging. We've got a children's toy if you don't understand what gauging is, but basically we want to get round toys through round holes and don't want to put a square toy through a round hole. what I want to look at here is the standard gauges, and it's the W10, W12 gauge, if they mean anything to you, but essentially they're freight gauges. They're existing. They've been developed over quite a few years, but modern freight gauges, there is a conflict. What this meant was for certain wagon combinations to travel on certain routes, you needed to do an individual gauging assessment, which wasn't efficient, and it was not promoting freight growth at all. So we had these research questions: can they be adjusted to make more combinations, and can we open up more routes? And the benefits are quite clear. So the outputs were really positive. We had allowed a lot more combinations. So for example, for W10, there were 64 new wagon container combinations. Freightliner FA wagons, there was an extra 4 combinations there. So really positive results. And we also opened up a lot more new routes. So over 300 on both. Those of you with eagle eyes will notice on the W10 route, there's a new route opened up in Scotland with absolutely no connections, which I quite enjoyed when I saw that. I don't know whether you sort of have to float the freight in by helicopter to go on that route, but anyway, it did open more routes. Maybe that one isn't that beneficial. So just to talk about now where the implementation is. So the findings have been produced and they're really positive, but now we need a standards project to update the standard to have a new freight gauges, and then that will be updated to section appendices. So we've got quite a nice implementation pathway, and then hopefully the freight community can realise the benefits of that. I'm going to just talk about track systems requirement, because this is sort of, it's a bit my, I was the standards engineer doing the update of the standards, so I sort of across both worlds here. But I was updating the track systems requirement and wanted to know about the curving rules. Were they still appropriate? Curving rules have been developed over lots of years, quite historic. Were they still appropriate for modern track design, or could we change them? So the University of Huddersfield did some work on looking at curving rules, and they found they did a lot of benchmarking against continental limits, and even into domestic limits such as metro, such as London Underground. They found that although in some cases our curbing rules such as cant deficiency were a bit restrictive, they also did offer better ride comfort, as it was validated by doing vehicle modelling. So what this did was give us confidence that the limits we were using were appropriate and facilitated the update of standard. One thing I would say is that it did actually highlight about virtual transitions, and again, I don't have time to do virtual transitions here, I'm afraid. Talk to me after if we want to talk virtual transitions, but it highlighted that actually the length that virtual transitions are currently calculated over, 12.2 meters, could be modified due to changes in rolling stock. So that was something where we did actually add a little bit of benefit and optimize it. I won't go on to the lateral track loading, I'm afraid, but you can talk to me after about that. And finally, it's a TransPennine upgrade. Dave Woods, who's organising this, is something close to his heart. And this is actually an example where research hasn't quite been successful. So, and I thought it was important to include this, because I think sometimes in these presentations it can be seen as research will solve all your problems, and it's not the case. It's not the nature of research. So window box clearances are a gauging sort of envelope that developed when it was common to have drop-light windows. People stick their heads out. It was operational practice for drivers to have a look out of a window to when they were shunting. But now those operational procedures aren't there, and very few rolling stock have drop-light windows, or windows you can put your head out of. But the problem with the gauging is we're causing a lot of deviations having to be submitted for the TransPennine upgrade group, because it goes through a lot of legacy tunnels with quite tight clearances, and if they were to optimize the track design, it was leading to these infringements. So we wanted to ask, can we modify these gauging requirements? Unfortunately, the research said that although the risk has reduced massively, there was still not strong enough justification to remove the limit. It provided some guidance and useful figures, such as the sort of 100,000 value, which has improved the deviation process, but it didn't give us the answer really we wanted. But again, that's the nature of research. So that's something just relevant for a transpennine upgrade, where we were trying to address that problem, whole system gauging problem. So to recap, hopefully you have an idea of what the RSSB research program is, what it does, what it addresses, what it doesn't address. I've given you a few examples. Hopefully you found them quite interesting. I could provide more examples, but these were ones I thought were relevant to sort of a PWI audience. What the future holds, I don't know. Ask someone from GBR, but hopefully we'll carry on doing sort of beneficial research for years to come. And as I said, I'd really make a plea that if you have research ideas, we want to hear them. And if you can help continue to promote and push and implement our research, then that will be very welcome as well. Thank you all very much. Cheers.
Thank you.